Good morning to all. I am Dr. Ganesh, Assistant Professor, Department of Aeronautical Engineering in the Sun College of Engineering and Technology. In this video, we are going to discuss about statically determined structures. Outline of this video is as follows: Introduction, types of stress, plane truss, statically determined and stability of trusses, analysis of statically determined plane truss, sign convention used. Trusses. Trusses is a combination of members joined together to form a structure. So here we have some practical examples of different types of trusses: electrical tower and a bridges, mobile towers and a stadium. And here we have some of the other examples of the trusses. Introduction. A truss is an articulated structure with hinged or ball and socket joints. It is an assemblage of slender members fastened together at their ends by smooth wings or ball and socket joints acting as hinges. In a truss, the joints are of pin type where end of the members can rotate freely. Moreover, individual truss member should not directly load transversely. Loads should be applied at the joints of members so that no bending or shear force will be generated on truss members. Self weight of the members should be dumped both ends for the same reason. Types of truss. There are two types of truss. The first one is plane truss, or also called as 2D truss. A truss consists of members which lie in a plane and are loaded in the same plane is called as plane truss. Example: roof truss, bridge truss, etc. So here we show the example of plane truss. The second one is space truss, or also called as 3D truss. A truss made up of members not lying in the same plane is referred to as space truss. Example: electric power transmission tower, microwave tower, etc. So here we show the example of 3D truss. So it may be a three-dimensional truss, x, y, z direction. So now we'll see the plane truss. The basic element of a plane truss is three members: bars, angles, tubes, etc. are arranged to form a triangle. To this base triangle, two more members are added to locate a new joint, and the process continued to form the complete truss. Here we show the triangular truss is the basic form of the plane truss. The types of plane truss. These are the various types of plane truss are used as a roof truss. So statically determines and stability of truss. So before analyzing any truss, so you want to check the stability of the truss. So let us assume M is equal to number of unknown member forces and C is the number of unknown constraint reaction components, usually 3, if statically determined externally, and J is the number of joints. Each joint has two equations of equilibrium. The first one is summation of H is equal to 0 and summation of V is equal to 0. Hence, the number of equilibrium equation available is equal to 2J. The total number of unknowns is equal to M plus C. So to check the stability of the truss, so if the total number of unknowns is equal to total number of equations available, then the truss is statically determined. That is, M plus C is equal to 2J. If the number of unknowns is more than the number of available equations, then the truss is statically indeterminate. That is, M plus C is greater than 2J. If the number of unknowns is less than the number of available equations, then the truss is unstable. That is, M plus C is less than 2J. So to check the degree of determinants, it's denoted as I. I is equal to M plus C minus 2J. The degree of external indeterminacy I suffix e is equal to c minus 3, and the degree of internal indeterminacy is equal to I suffix I is equal to I minus I suffix e, that is equal to m plus 3 minus 2j. When we consider the internal indeterminacy, we have the following cases of trusses. First case, when I suffix I is equal to 0, m is equal to 2j minus 3, and the structure is statically determined internally and is stable. Such a truss is called perfect truss. When I suffix I is less than 0, the number of members provided is less than the required for stability. Such a truss is called as unstable or deficient truss. The third case is when I suffix I is greater than 0, the number of members is more than the number of required. Such truss is called statically indeterminate. So it's also called as redundant. When we consider the external indeterminacy, we have the following cases of truss. The first case is when C is equal to 3, that is I suffix E is equal to 0, the truss is said to be statically determined externally. Second case, when C is less than 3, that is I suffix E is less than 0, the truss is said to be unstable externally. The third case, when C is greater than 3, that is I suffix E is greater than 0, the truss is said to be statically indeterminate externally. The assumption made in the analysis are as follows. So when we are analyzing the truss, so we want to consider some assumptions. The first assumption is the members of the truss are connected at the ends by frictionless hinges, and the second one, the axis of all members lie in a single plane called middle plane of the truss. The third one is all the external forces acting on the truss are applied at the joints only, and the fourth one, all the loads are applied in the plane of truss. The following methods of analysis will be adopted to analyze the plane trusses. The first one is the method of joints, and the second one is method of sections. The sign convention used in the analysis of trusses: positive sign is used for tension, negative sign is used for compression. So when the tensile load is acting on a member, it will be considered as a positive sign. When the compressive load is acting on a member, is considered as a negative sign. Thank you very much for watching this video. Thank you.